Everybody. Welcome to week 6. It's the last week that any new work will be assigned to anyone throughout this at-home learning. Once again, I just want to commend you guys on doing such a great job in such a difficult situation. Many of you have just been knocking this out of the park, getting stuff done right away. It's been a great job by you guys. So I'm really proud of the work that you guys have put in. We're going to talk this week about determinants of matrices. Okay, so first thing about determinants is they only occur in square matrices. So, 2 by 2, 3 by 3, something along those lines where their rows and columns are the same. Okay, so let's go ahead and if I can get this going. All right, so this is how we will find the determinant if we have a 2 by 2 matrix. All right, what you're going to see is we're going to take, if we have, that's what, by the way, these little lines right here, if it doesn't have a little bracket and it's just lines, that means determinant also. So if you see that, that's what that's talking about. So what we will do is we are going to take the number in the top left corner and the number in the bottom right corner, all right, diagonally, and multiply them together. And then we will take the other numbers, A2, B1, the bottom left, top right, multiply them together, and we are going to subtract the difference, okay, always starting with the top left first. Okay, so that's what you see right here where it says A1 times B2 minus A2 times B1, and determinant will always be one number. Okay, it's going to get one number answer. It's not going to be a matrix. So let's go through an example of it. They're pretty easy with the 2 by 2s. Okay, so example 1, here we go. We're going to first off do 5 times 3, and then we will put a subtraction sign. We got 7 times 6, so that would be 15 minus 42, which is a negative 27 as our determinant. Okay, sometimes you'll see it say the word, like the letters det in front of it. That'll tell you if you need to find the determinant, or the instructions will just say to do it. Okay, let's try the next one. Okay, so we have 2 times negative 5. So if we cut out a little bit, let's just write it out. Why not? Okay, so 2 times negative 5 minus negative 3 times 4. So negative 10 minus negative 12. We know we got to boom ching that thing. That leaves us with a positive 2 as our determinant. Okay, so scroll down a little bit, and I believe, come on. You guys are laughing at me if you're watching this. There we go. There's the checkpoints that you guys will have a chance to work on yourselves. Okay, so here's what we're going to work on now. Okay, it's a little bit more complex, but we can actually solve systems of equations like you did at the very beginning of this whole shebang by using determinants. Okay, it's a little bit complicated, but if you like puzzles, this isn't a terrible thing to do. Why can I not scroll this thing? What am I doing wrong? There we go. Okay, so what you're going to see is we're going to take the determinant of a matrix that's made by the coefficients, and we're also going to make a matrix using the numbers that are on the answer side of the equations, okay, the constant terms. So we're going to kind of set those up, and that's going to how we're going to be solving for x and y. All right, so let's go through an example of this, and we're going to need our equations here. So we see x equals, let me do this. Let me see if this will work for us. Should have done this ahead of time, huh? That would have been smart. I'm not going to do it. I'm not going to bother. Okay, so x equals, notice the c's, okay, the numbers that are on the other side, they're replacing the first column, so you can remember that when you're doing x. Okay, so it's going to be a 2 and a 1, and then we have the rest of our equations, negative 4 and negative 5, and we are dividing that by the determinant of just the coefficients. So 5, negative 4, 6, negative 5, okay, because this is A, B, and C. That's how we're finding those. All right, so I want to make sure that you're always referring back to those equations. I'm sorry, the formulas. So if we do our determinant, we have, whoops, 2 times negative 5, so negative 10. Negative 10 minus 1 times negative 4, so negative 4. And the bottom we have 5 times negative 5 minus 6 times negative 4. Okay, so when we go ahead and simplify all of this, it leaves us with a negative 6 in our numerator. Boom ching here, which leaves us with a negative 1, which gives us 6. That's our x value, okay? So in order to find the y, we're going to do kind of the same thing. Okay, so let's go ahead and do this. And you guys are like, man, this video is awful. Does this guy even know what he's talking about? And the answer is, who knows? Okay, so 5, negative 4, 6, negative 5. And then notice, like we saw in the formula, the numbers that are our answers, the C value numbers, are going to take place of whichever side that we're finding. So we're finding the y's. So the 2 and the 1, in this case, they're going to go on the right side, and the 5 and the 6 are going to stay put. Okay? So once again, follow your formulas. Pay attention to those. As long as it's going to go A, B, C. Okay? A is the x coefficient. B is the y coefficient. C is the constant over on the other side. Okay, let's do this. So 5 times 1 is 5, minus 6 times 2 is 12. All right, and then the bottom, negative 25. This is going to be the same thing. Minus negative 24. Leaves us with a negative 7 on top. You boom ching this, which leaves us with a negative 1. Negative 7 divided by negative 1 is 7. That's our y. So our final answer here is going to be an ordered pair. Our x value is 6. Our y value is 7. Okay? So it's a little tricky, but you might find that a little faster if just plugging some numbers in. You might find that to be a little bit easier than actually going through and doing elimination or something of that sort. Okay, let's go ahead and move on to one of our other examples here, and that is example 3. And this is going to be how we're going to find a determinant of a third order matrix, which means a 3 by 3. Okay, now it's a little bit, how do I say, tricky. All right, so what you're going to notice here, this is the formula, okay? What you'll see happening is we're taking the numbers on the left column, the first column, and we're kind of splitting them up. All right, and it kind of follows this whole thing. So this is not something to memorize. So you're going to want to make sure you pay attention to it. You see the A1, the first element here, we're going to multiply by the determinant of the rest. So if you take A1 and pretty much cross out the row and the column it's in, this matrix that's left over inside of here is what we're going to find that determinant, and we're going to multiply by what that number was. Okay. Likewise, when we go to the second one, we do A2. All right, when we go to find A2, you're taking cross off that column, cross off that row, B1, C1, B3, C3. Those are the ones that are left. Okay, and then likewise, if we're finding this one, A3, cross off, we're finding the determinant here. Okay? So, I'm going to go through this now. Once again, we do have graphing calculators that are available. Oh, there's that thing. We do have our graphing calculators available. I'm just going to show you something really quick before we get into this problem. And that is, if you go to second matrix and you have all the same thing we did the last couple of weeks, you go over to edit if you're going to change the matrix. But when you go over to math, you see the first thing is det. Okay, that stands for determinant. So you could actually just edit your matrix, hit determinant, and it will solve it for you. Okay, it's a nice little shortcut. I'm going to go through how to do this other one just because some people might enjoy the process. All right, I know a lot of us just, we enjoy getting that answer, and it's all well and good. But let's go through this at the same time. So here's how it's going to go. Remember, this is A1. This is the A column. This is the B column. This is the C column. Okay, so A1, which is 4. Let me scroll up so we can see the... I bought this computer just for this purpose, and it is not easy to use in this sense. And there we go. Okay. Come on. Okay, so we have A1, which is 4, and that's going to be multiplied by the determinant of the matrix that's left. So once again, if you take this, cross that off, these are the numbers here that are left. So 3, 4, 8, and 1. I'm going to erase this all. 3, 4, 8, and 1. Now, minus A2 is our next thing. That's a negative 9. And then if we cross off the column and the row that it's in, we have the top row and the bottom row. 1, 0, 8, 1. 1, 0, 8, 1. Oops, I made a mistake here. I should not have made that look like a matrix. It should be the determinant lines. There we go. All right, and then lastly, we're going to add A3, which is negative 3, times the determinant of whatever is on the top 1, 0, 3, 4. We're not using that bottom row. All right, so carry down this 4, and we're going to multiply it by the determinant. So let's see. 3 times 1 is 3, minus 8 times 4, 32. Excuse me. Minus negative 9. Well, wait till the end to do that minus negative stuff. But 1 times 1 is 1, minus 8 times 0, well, that's 0. And then plus negative 3 times our determinant. 1 times 4 is 4, minus 3 times 0 is 0. So this leaves us with 4 times negative 29. Feels like that's the wrong answer, but we're doing all right. Minus negative 9 times 1 plus negative 3 times 4. I need to get a new little pen to use with this thing. Go away. Go away. Go. This is driving me crazy. Okay. So last, let's solve this. So 4 times a negative 29, that's going to give us negative 116. Minus negative 9 times 1 is a negative 9, so that's going to be a plus 9. And then minus a plus a negative 3 times 4, which is a negative 12. Okay, so once we add all that together, negative 116 plus 9 is negative 107. And we subtract 12, which is a negative 119. And that is our final answer. Could we have gotten that a lot quicker using our calculator? Sure. But once again, those of you that kind of enjoy going through problem solving, it's kind of a fun little exercise for you, okay? All right, so example 4, it's just another example of the same sort. So I'm going to go through that one. Hopefully maybe it'll be a little bit neater. So let's do this. 9 times the determinant of... Shoot. Remember when I said it was going to be neater? So much for that. Negative 3 and 0, 4 and 2, minus... All right, remember that's a minus in the middle of it. Negative 2 times the determinant 5, 0, 4, 2, and then plus 1 times the determinant of 5, 0, negative 3, 0. Boy. So 9 gets multiplied by, we have negative 3 times 2, which is negative 6, And then 4 times 0, well, that's great. That goes away, minus 0. So we have a negative 6 minus negative 2 times our determinant here. 5 times 2 is 10. 4 times 0 is 0. So that 10 minus 0 is just 10. Plus 1 times 5 times 0 is 0. Negative 3 times 0 is 0. That leaves us with a 0 here. So we have a negative 54, multiplying the first two. Okay, minus negative 2 times 10. Well, negative 2 times 10 is negative 20. So it's going to end up being a plus 20. And then at the end is just a plus 0. Leaves us with a negative 34 as our determinant. And ladies and gentlemen, if you stuck with me all the way through the end of that video, God bless you. That was a rough one. That was probably the worst one yet. I got to be honest with you. But once again, if you have any questions on anything, feel free to get a hold of me. And this is the last time I'll have a chance to actually talk to some of you guys. So I want to take this time to really wish you the best of luck. I really wish that the circumstances were different. Obviously, we all do. But hopefully you're doing well, and everything's going to kind of turn back around in our favor pretty soon here. Okay, as long as we just kind of push our way through this whole mess. So once again, it was an absolute pleasure. It was a blast being your guys' teacher this year. And I wish you all nothing but the best. Those of you that'll be in school next year, please feel free to stop by and just say hello, okay? Or just yell at me for making you take calculus, one or the other, okay? But once again, wishing you all, everybody, the best. Have a great, great summer, great careers, great futures, and that's about it. Okay, so once again, have a great one.